Hello, everybody. Good to see you all back. Ciao. So, we had last session talked about a fantastic concept called as the electron transport system, and today we go into an absolutely superb logic called as the chemiosmotic hypothesis. Superb logic, not given at all properly in the NCRT or even in our notes. It's a great logic which I want you all to understand. किसी भी book में ये बराबर से दिया नहीं है. But we are going to do this in tremendous detail. I'm going to explain you what is chemiosmotic hypothesis. Let's see what that is. Before we go into chemiosmosis, just a quick fire recap of what we had done in the last session. I hope you remember glycolysis takes place in the cytoplasm. Glucose becomes pyruvic acid. Pyruvic acid enters into the mitochondria, into the matrix. In the matrix of the mitochondria, it undergoes the Krebs cycle. So, Krebs cycle takes place in the matrix. And Krebs cycle से बनते हैं NADH plus, NADH plus H plus, and FADH2, and these will undergo the electron transport system ETS, which will take place on the inner mitochondrial membrane. Before we go into the ETS, more detail, Krebs cycle में बनेंगे NADH plus H plus, which will first form NAD, and the hydrogen is accepted by FMN to form FMNH2, and the FMNH2 will again form FMN is accepted by coenzyme Q to form coenzyme QH2, which will then again form coenzyme Q. I hope you all remember, all of you. So where has hydrogen gone from? NAD to FMN to coenzyme Q, and coenzyme Q has become coenzyme QH2. ये हमने किया था last session. Now coenzyme QH2 will again become coenzyme Q, and the two hydrogen will now split to form protons and electrons, of which protons will remain in the matrix. Protons matrix में ही रह जाएंगे, but electrons will pass into the inner mitochondrial membrane, where it will pass through electron acceptors. If you remember, B, C1, C, A, and A3. And after passing through electron acceptors, electrons will pass through the electron transport system on the inner mitochondrial membrane. Then these electrons, after passing through B, C1, C, A, A3, electrons now are accepted by oxygen, and oxygen will go back into the matrix. And in the matrix, what does oxygen with electron do? It combines with protons which were left in the matrix and forms water, which is called as terminal oxidation. So this is what we had done last session. Now, more diagrammatically, where had hydrogen gone from? NAD to NADH2, then to FMN to FMNH2, then to coenzyme Q to coenzyme QH2, and from coenzyme QH2, the hydrogen had split to form protons and electrons, of which protons remain in the matrix and electrons pass through cytochrome B, cytochrome C1, cytochrome C, cytochrome A, cytochrome A3, which is on the inner membrane of the mitochondria and is accepted again by oxygen, and oxygen along with electrons and protons will form water. And what is that phenomenon called as? Terminal oxidation. So there was hydrogen transfer in the matrix. NAD to FMN, FMN to coenzyme Q. There was hydrogen transfer in the matrix. There was electron transfer. Electron transfer was on the inner membrane of the mitochondria, where electron is passed from cytochrome B to cytochrome C1 to cytochrome C to cytochrome A to cytochrome A3 to oxygen, and then electrons with oxygen and proton combine together to form water, which is called as terminal oxidation. ETS. And if you remember, between NADH2 to FMN, the hydrogen releases energy, and that energy combines with ADP and IP to form a molecule of ATP, which is called as complex 1. And during transfer of electron from cytochrome B to cytochrome C1, electron liberates energy, which will again combine with ADP and IP to form a molecule of ATP, which is called complex 2. Oh, sorry, complex 3. I'm so sorry. That is called complex 3. And then between cytochrome A and cytochrome A3, again electron is given with energy, which combines with ADP and IP to form a molecule of ATP, and that is third ATP form, which is called complex 4. So how many ATPs are formed? ATP bante hai 3. One is between NAD to FMN, that is called complex 1. Second is between B to C1, that is called complex 3. And NAD FMN के बीच में 1 ATP complex 1, and B और C1 के बीच में one more ATP called complex 3, और A और A3 के बीच में one more ATP which is called as complex 4. So first ATP, second ATP and third ATP, 3 ATP बन जाते हैं between NAD FMN, between BC1 and between AA3. इस तरह से 3 ATP बन जाते हैं. These are 3 ATPs formed, and this is called as root 1. इसे root 1 कहते हैं, involving NADs. But समझो you have succinic acid to fumaric acid. This is called root 2, where FAD becomes FADH2, FADH2 again becomes FAD, and enzyme, the hydrogen goes directly to coenzyme Q, which is called ubiquinone, which becomes coenzyme QH2, which is called ubiquinol. And इस hydrogen transfer में ATP नहीं बनता है, ATP नहीं बनता है, that is called as complex 2. So root 2 के अंदर complex 2 में ATP नहीं बनता है. Between FADH2 to coenzyme Q, ATP नहीं बनता है, that is called complex 2. And then electron goes from B to C1, उसमें ATP बनता है, which is called complex 3. And then electron goes from A to A3, उसमें एक एटीपी बनता है विच इज कॉल्ड कॉम्प्लेक्स 4। तो कॉम्प्लेक्स 2 में एटीपी नहीं बनता है, कॉम्प्लेक्स 3 फॉर्म्स फर्स्ट एटीपी एंड कॉम्प्लेक्स 2 फॉर्म्स सेकंड एटीपी। सो रूट 2 में कितने एटीपी बनेंगे? रूट 2 के अंदर फ्रॉम सक्सिनिक टू फ्यूमेरिक एसिड FAD2 FADH2 FADH2 टू कोएंजाइम Q में कॉम्प्लेक्स 2 के अंदर no ATP is formed. No ATP is formed in complex 2, and then between B and C1 one ATP is formed which is complex 3, उसमें ATP बनता है। Between A2 A3 one more ATP is formed which is called as complex 4, and these are called complex 1 2 3 4. And if you remember, which are the actually there are 5 complexes. Which are the 5 complexes? NAD2FMN is called complex 1, B2C1 is called complex 3, A2A3 is called complex 4, and FADH2 to coenzyme Q is called complex 2. And these are 4 complexes, of which NAD2FMN complex 1 forms an ATP, B2C1 complex 3 forms an ATP, A2A3 complex 4 forms an ATP. So these are 3 ATPs formed, but FADH2 to coenzyme Q complex 2 does not form ATP. No ATP is formed. All this we had done, and then I had told you कि ये सब actually incomplete है। तो ये actually ETS complete नहीं हुआ है। Where are the actual ATPs formed? Actual ATPs are formed in the F1 particles. तो ये F1 पार्टिकल के अंदर एक्चुअल एटीपी फॉर्म होता है, एंड दैट F1 particle which is present on the crystal where you have base, and then you have base, you have stalk, and you have head. You have base, you have stalk, and you have head, and these are the actual F1 particles or oxysomes. उसके अंदर हेड को कहते हैं F1 particle. Head has in it F1 particle, and F1 particle में होता है एक एंजाइम कॉल्ड एज ATP synthase enzyme. So in the F1 particle is found the enzyme called ATP synthase enzyme, and ATP synthase enzyme is called complex 5, and it is complex 5 which actually forms ATPs. So complex 1 3 4 जो हमने यहां किया, 1 and 3 and 4, इनमें एक्चुअली एटीपी नहीं बनता है। नो 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 नो, so they don't form ATP. There is ATP actually formed. ATP is actually formed in the head of the F1 particle with the help of ATP synthase enzyme, and that is actually called as complex 5, and all the ATPs are formed by complex 5. That is something called as the chemiosmotic hypothesis. Chemiosmotic hypothesis, which we will do now. तो अब तक हमने सिर्फ रिवीजन किया है, अब हम लोग स्टार्ट करते हैं द रियल ब्यूटिफुल कंसेप्ट कॉल्ड एज chemiosmotic hypothesis. Let's analyze that.